The last part of MI will be questions including the summation symbol, where you can see it's a very terrible symbol here. It is an abbreviation of summation sign, and then so let's take a very quick review of what does it mean. For example, if we talk about k is 1 to 40 for k square, actually the k square means the kind of like formula, and then so starting from k is 1, that means starting from 1 square, you want to add up everything until 40 square, So as a result, according to the formula k square, I'm adding up 1 square, 2 square, 3 square, until 40 square. This is the meaning of the abbreviation of the use of the summation sign. Now when you want to deal with a question with summation sign, one of my suggestions is don't look at the summation sign itself, but you're trying to write down the terms explicitly. When k is 1, you have minus 1 and 1 square. Next you have minus 1 square, k is 2 square. Next term is minus 1 cube, 3 square, so and so, until the last term is called minus 1 to the power n square over there. So with this, it helps you to understand the question in a better way. Now let's start part A together, and I will say let Pn be the proposition. But this time I prefer to write down the things clearly because the question itself is in summation sign. So that's why I duplicate the terms I wrote in green onto my answer. 3 square until minus 1 to the power n, and then n square, which is equal to minus 1 to the power n, and then n plus 1 over 2. So now we start the second part when we say when n is 1. When n is 1, the left-hand side is only one term, so which gives you minus 1 and 1 square, which is minus 1. While for the right-hand side, you have minus 1 to the power 1, 1 plus 1 is 2, over 2 is also minus 1, that means the left-hand side. So that's why we say P1 is true. Afterward, we assume Pk is true. So once again, you remember that I would suggest you to write the outcome clearly. That means now I have minus 1, 1 square, minus 1, 2 square, minus 1 cube, 3 square, until minus 1 to the power k square equal to minus 1 k times k plus 1 over 2. And now we start looking at when n is k plus 1. Once again, it's better for you to write down the m over there. So this time it should be minus 1, 1 square, add up to, originally the n term is minus 1 to the power k square, and now with one more term is minus 1 to the power k plus 1 square. And according to the result, my aim is equal to minus 1 to the power k plus 1 plus 1, that means k plus 2 over 2. And this is our aim. So when you do anything onwards, your aim will be the expression as follow. Okay, let's start for our calculation. When n is k plus 1, your left-hand side becomes minus 1, 1 square, minus 1, 2 square, minus 1 cube, 3 square, up to original last term is minus 1 to the power k square. Next, we have one more term called minus 1 to the power k plus 1 square. For the first k terms, so very ugly. Okay, the result will be minus 1 to the power k, and k plus 1 over 2. And now we have one more additional term called minus 1 to the power k plus 1 square. So now we can simplify it by taking out common factor. We have minus 1 to the power k, minus 1 to the power k here, k plus 1 and k plus 1 here. These are the two common factors I find at first. So we have minus 1 to the power k, k plus 1. So the things left will be k plus 1 over 2, and you have minus 1 and then k plus 1. After having the same denominator 2, you have k plus 1 minus 2k minus 2, which gives you minus 1 to the power k, k plus 1 minus k minus 1 over 2. And then now we can put it in a big fraction with denominator 2 because of the minus sign which is taken out. So that's why minus 1 will be raised up to k plus 1 as a power. And after you take out the negative signs, so you have k plus 1, which gives you k plus 1 squared. So that's why we say pk plus 1 is true. And by the principle of mi, Pn is true. So this is the situation having a summation sign in your mi question, but indeed. So the main point is you need to know how to expand it into the expression like this one or this one, and then so that you can do the calculation accordingly. In your examination, there is always again a hard question or follow-up part, and then so let's take a look on this question. Well, the question, there are two troubles. First of all is you see is k plus 1 but k in the formula, and then k is not starting from 1 but it's starting from 3. But by the way, you can see that it's quite obvious to tell you, so you are putting n to be 333 into your formula. So that's why I will start from it and see the question respectively. And then now, okay, so let's take the free space. Follow. Okay, so for our convenience, I duplicate or copy the question here. I'm going to find k is 3 to 333 minus 1 to the power k plus 1 k squared. So you want to know the value of it. And then in the question, as I mentioned before, so from A, so let's start from putting n to be 333 first. As a result, the outcome in part A tells us that if we sum from 1 to 333 of minus 1 to the power k and k squared is equal to minus 1 to the power 333, 333 and 333 plus 1, that means 334 over 2. Wow, so many 3's. Okay, next on the right becomes from calculator is minus 55611, and then so here comes our result. In order to fit with the formula, I need minus 1 to the power k plus 1, so that's why the power is missing. So that's why I might multiply minus 1 on both sides, which becomes summation of minus 1 to the power k plus 1 k squared, and then on the right becomes 55611 accordingly. And then so we settle the first part. Second part is how we deal with the 3 over there. But now we have been starting from, we are starting from 1 here. So that's why I would take out the term 1 and term 2 from the formula so that we can move it to the right hand side afterward. So now we do the calculation by ourselves. So for the first term is k plus 1, k is equal to 1. According to formula is minus 1 square and a 1 square. the second term will be called putting k is 2, which means minus 1 to the power 3 and then 2 squared. And then so our job is to remove the term to the right, and we can get the result. Okay, let me check. Which is equal to 55614 finally.